initialize Genesis sequence.
Hey, good morning. I am Tim Berglund. This is a brief history of data. Thanks for being here on the final round of DevOps, first talk in the morning, first thing in the morning. It's great to see your faces here. I work for a company called Confluent. I run the developer relations team there. I usually talk about Kafka and Flink and technologies related to that whole part of the world. This is a little bit of a zoomed out perspective on data. I've just been very interested in just generally the history of computing recently. I don't know if that's an age thing or just a phase. I don't know what it is, but there's a lot of interesting stories to tell. And I want to try to gather some of the threads that come together to give us the thing that we receive as data and the data ecosystem now. We're going to take a timeline perspective here. I'm going to take you through time. The danger of doing history, number one, as a not historian, I'm not a historian, but the danger of looking at history on a timeline is that sometimes it can kind of create this sense of this inevitable progression of events that had to lead to a thing. And I don't mean to convey that, but I do want to just step through time and kind of gather some threads of some ideas that all have to come together. Ideas like the way we think about statistics, automatic computation, data storage, centralized compute and data, decentralized compute, the global scale of the internet, big ideas like mainframes and client server and events, all these threads that kind of happen over time. We gather them together, we end up in a place that informs who we are, what we do right now. That's the story I want to tell. And I want to start in maybe the early 1800s, late 1700s. Governments had kind of recently begun collecting statistics about their populations in a new way. And this was automated. This was just, people writing things down on paper, but things about their population, when people are born, disease outbreaks. Censuses weren't a new idea, but there was all of a sudden a bunch of data lying around. And there was this guy, he was from Belgium, Adolphe Quetelet. He was from Brussels, and in the early 1800s, he was a young astronomer, and he wanted to build an observatory in Brussels. And back then, you could build an observatory in a major city because it still got dark at night. That's not really a thing anymore. He secured the funding, but there were some delays, bureaucratic things, and he couldn't build his observatory. Now, what he wanted to do was use the observatory to take astronomical measurements and learn things about the heavens. He couldn't do that, so he said, hey, wait a second, there's all this demographic data that we have here in Brussels. Let me play with that. And so he kind of set his mind to measurements of things about people. Now, the way astronomers were taking measurements at the time is, they'd say, measure the position of a star or maybe an asteroid or a comet relative to stars. You take that measurement a bunch of times and you average it. Maybe you have different people take the measurements. You average them, and the average is the truth. It's the actual position of the thing. Well, he applied this to people, and he thought, let's take all these averages and let's come up with this kind of average person, and the way the averages line up will be some sort of true state of the way people are. Now, that might sound a little shady, and it was. Adolf wasn't a bad guy, but his legacy, when you actually read the legacy of the folks who follow in his footsteps, it gets dark very quickly. It just goes to super bad places. And so that's a little unfortunate, but this idea of gathering statistics about a population and analyzing them and trying to get some insight from a reduced value from a large set was a new idea. Oddly, it seems so commonplace to us, but this guy's the one who kind of kicked that off. Again, people took it in some shady directions, but that's not Adolph's fault. Let's just leave that. So we've got that idea of just call it analytics, right? Is sort of becoming a thing. Now, Charles Babbage in the 1820s, 1824, I think, is the beginning of this stuff, wasn't the first guy to build an automatic computing machine. Blaise Pascal had done that 200 or so years, 150 years earlier. But this is where automatic computation really starts to pick up some steam. And a lot of folks know Babbage's story and what he did, but we don't all know why he did it. He was motivated by these books of numbers. If you needed to know, you didn't have a scientific calculator with a cosine button on it or a log button. If you needed to do calculations with transcendental functions in them, you had books with those numbers printed in them, or books with astronomical measurements printed in them. And you'd buy that book and you'd have the entry. And he was really, really bothered by the fact that sometimes there were mistakes. And, that stinks. You don't want a mistake in a book like this. And, the Industrial Revolution is just kicking off, and he's got this great quote. He said, "I wish to heaven these calculations could have been executed by steam." Like there's a mechanism that could do this. And so he made one up. He made the difference engine and later the analytical engine, and he partially built a version of his difference engine, which was a machine that that basically found the roots of polynomials, is what it did. You could put in the coefficients of the polynomials, you crank it, and it would find roots automatically. And even in his mind or on paper, designed a version that would automatically print that out. So he's like, I'm going to make perfect freaking log tables with no mistakes, because he just couldn't handle the fact that these things happened. This is a portion of his analytical engine that he actually built. This was just like the equivalent of the ALU portion of it. He never built his whole analytical engine, never realized that whole vision. It wasn't realized until, I think, 2002 by a team led by a guy named Doron Swade, who, by the way, has got some great short history works on computing that are very much worth reading. And the full version of the difference engine, not the analytical engine, was built then. Very cool stuff. So Babbage is kicking off this idea of we need automatic computation. But he has a very limited vision, right? He just wants to print perfect tables of numbers. That's really what he wants. Okay. And he builds this in his mind. He designs this analytical engine, this computer that you could program. And a lot of us know about his correspondence and friendship with Ada Lovelace, who we normally think of as being the first computer programmer, because she, in her mind, designed programs for this machine that didn't even exist, which she actually did. Very, very fascinating character. Her history is really worth knowing something about if you want to dig into that. Her dad was Lord Byron, the poet, not such a great dad. Like, you could aspire to be a better father than Byron. Her mom really invested in her and encouraged her study of math and everything, which she definitely did. She's credited as being the first computer programmer. Here's a little wrinkle. That's a bummer. Babbage himself did that same thing, writing kind of made-up programs for this made-up machine. He's got published analytical engine programs earlier than Lovelace's first analytical programs, analytical engine programs. But here's the contribution that Ada made that is, I think, even more groundbreaking. Babbage's vision was for this machine that could print tables of logarithms and trig functions and do it perfectly. That's great. I love that journey for him. The problem with that is the problem wasn't really all that bad. There weren't that many mistakes, and people would find them and issue a correction, and it was like fine. And in competition for government funding for his machine versus other, say, projects that the Royal Astronomer wanted to fund and things like that, in fact, the Royal Astronomer at the time was a huge opponent of Babbage's. Said, this machine is a huge waste of time. We don't even need this thing. The problem of a log function in the table being wrong sometimes, not really that big of a problem, Charles. What Lovelace saw, though, was the idea of general purpose computing. She is the one, Babbage never saw this, she is the one who saw what this machine could be. In fact, she wrote about the idea that, the notes of a symphony, this thing is just a machine that deals in numbers. You could assign numbers to the notes of a symphony and create a program that creates a symphony. It's all just numbers, and this machine could do that kind of thing. Literally thinking about generative AI in the 1820s, 1830s, a long time before we did. So it's not quite precise to say that she was the first computer programmer. It's 100% precise to see that she's the first one to see the potential of what computing could actually be, which is really, really cool. So you got Babbage establishing this idea of automatic computation. For data to be the thing that it is, whatever it is that we deal in, automatic computation is one of these threads that has to exist. So you've got this Belgian astronomer kind of kicking off the idea of analytics as we understand it, Babbage and Lovelace giving us the idea of automatic computation, and that keeps going. A few decades go by, Babbage's project dies. Again, his use case that he's selling is perfect trig function lists, and nobody cares. And so the project dies, and it doesn't go away. It doesn't get worked on. But then in 1880, the United States is experiencing massive waves of immigration, and it's a requirement of the U.S. Constitution that we take a census every 10 years on the decade boundary. It's a thing. It's just written down. It's the law. And so the census in 1880 was all done by hand and tabulated by hand. It took 8 years to tabulate. And the United States experienced about 25% population growth in that decade. And so they're staring down the 1890 census saying this isn't going to work. It's going to take longer than 10 years to process each census. And this guy named Hollerith comes along and he says, it's okay, I've got this machine, you can punch the data into these little cards and stick it into my tabulating machine, and it will sort them, and it will add things, and it will let you process your whole census in a year instead if you just buy a bunch of these machines. It was great. It was a huge success. Actually enabled the 1890 census to get done and kicked off an industry. A few years later, it was combined with a couple of other companies to make a company called the Computer Tabulating Recording Company. That's a great name. Maybe CTR sounds cool. You call it CTR. I like the sound. That was 1911 is when this happens. And in 1924, that was renamed International Business Machines. So that is where IBM comes from, an American having the idea of making a machine that could sort and tabulate cards. So automatic computation is off and running. Pretty soon, we're going to need to add data storage to that, and we'll see how complicated things get. But let's just keep walking through this history. Obviously, we have to mention Colossus. This is a series of machines built by the British in World War II to help break Enigma codes. And again, that is a really interesting story that you can dive into all on its own, and I'm in a room like this, I'm sure many of us have. It wasn't like you took an intercepted message and just sort of typed it into this computer and it translated it. There was a bunch of work that had to be done before that in the input, and the machine would help create likely decrypts of the message. And there were about 10 in operation by the end of the war. And this wasn't a computer the way we think of it. You didn't write a program and store it in the computer and have the computer execute the program. It was programmed using, configured with switches and wires and things like that. I guess it was kind of like YAML. I don't know if that's the equivalent of YAML. I would rather, this is not a talk that's hating on YAML, but it would just feel more fun if you could do it with like a plug board, That's a good. Okay, there's an idea for a talk. Be a good demo. Look, we're going to configure Docker with... I'm super distracted now. I want to do that. All right, back to the history of computing and data. The first widely recognized stored program computer is this machine called the Electronic Numerical Integrator and Computer. We all know that in our profession, naming things is hard. Clearly it is. But ENIAC is a much cooler name. That sounds, vaguely cerebral somehow, or some like super brain thing. I wonder if it did in 1944 or 1945 when it was created. But there are a couple of guys, John Mauchly and Presper Eckert at the University of Pennsylvania. And this machine could do about 500 floating point calculations per second, and weighed tons and took kilowatts of power, and et cetera, all the statistics on that. It was crazy. This was not a commercial machine. This was an academic project. But those same two men, Mauchly and Eckert, in 1951, created a product, started a startup and created a product called the Universal Automatic Computer, UNIVAC. This was the first computing tech startup, and their first customer was, again, the U.S. Census Bureau. So it's governments, and in this early stage, you have to be a government or some kind of global scale operation. Airlines are becoming that now, utility companies, banks, somebody that operates at some massive scale. Because computing and data is so expensive, you have to have that scale to justify the cost. And these are, this was about 4 times faster than ENIAC from a few years before. About 80 of these machines were made, so big ticket items. There just weren't very many customers for computers. And they were batch analytics machines. That's what they did. You fed data in on a magnetic tape or on punched cards that somebody sat at a little machine and punched, and they did batch analytics on that stuff. And to be worthy of getting that output, like all of us can make and look at dashboards all freaking day long at work now. It's like they're free. To be able to get a report from one of these, you had to be somebody. Again, there are 80 of these machines in the world. This is not your mid-level, senior manager of minor paperwork operations. This is like important people get the output of these machines. All right, hard disk drives. Why does this matter? Well, if everything is on magnetic tape or punched cards, I guess you could kind of call that streaming data. I mean, it's sequential. Stuff comes in a stream, right? But that's, no matter what, if that's where I get stuff from in my computer, what I do is I analyze batches of data. There's no notion of a database on punched cards or magnetic tape. So we need to see a different storage technology. And in 1956, IBM releases the IBM 350. They're a huge part of the story of computing at this point. This is a 3 3/4 megabyte hard drive giant thing, that like a group of men, they were, a forklift or something lifts. And now you had a random access storage device, which led to, over the next 20 years, a series of different kinds of databases. Now it's possible to create something that's like a database. And it's this period of experimentation. Nobody quite knows what a database should be. Like, here's the world of things. How do I store those here? And you see this over and over again. We collectively, as a community, and this is our grandparents or great-grandparents at this point here, are kind of like stumbling around in the dark, trying to figure out the right way to get something done. We come up with a bunch of solutions. Not all of them work. Some of them do. And you really see that happening with the databases that are deployed over the next few years. We'll talk more about them in a minute. 1959. This, by the way, we are in the era of mainframes now. The IBM 1401. Now, if you're ever in Mountain View, California, I happen to live in Mountain View, California right now. I'm staying there for a period of a couple years. It's a beautiful city. It's where my employer is headquartered, and it's California's funny. For Californians, I mean, I'm an American, so I see like the train station in the middle of town that just looks like this really old building to me, right? It's so old, it's amazing. Californians are like the extreme of Americans. If you see a building that's from 1920, they're like, wow, that's really old. I come from Colorado, and like we have some buildings that old, but not on the coast of California. So, it's a new place, but the Computer History Museum in Mountain View is fascinating. If you're ever there, please spend half a day there. They actually have 2 working IBM 1401 mainframes. There's a demo. You can have your name printed out by an IBM 1401. It's super cool. They thought they would make about 4,000 or 5,000 of these over the lifetime of the product. They had 5,200 orders in the first 5 weeks. This is the first mass market computing device. And it was a tremendously successful machine that ended up all over the place. But there's still, and by the way, databases are starting to emerge around this time because you've got hard disks. We talk these days about this big difference between transactional data and analytical data, or maybe some people say like the operational estate and the analytical estate. And there are these two, there's the data warehouse over here, and there's my application database in sort of traditional terms. And that feels like a big division to us. It didn't really even start to become a division until maybe the early to mid 60s, because there had been so much emphasis on computers being batch analytics machines. Data was this big pile of static stuff that you dumped into a machine and got an analysis out of. Data wasn't things happening in the world that I type into a computer and the computer remembers them. So the idea of a distinction between transactional data and analytical data didn't really even show up until about 10 or 15 years into the world of mainframes. We're in the 1960s. And the introduction, this is the IBM 2260, their first standard terminal product, 1964. Terminals weren't in widespread use really until the 70s, the late 60s, early 70s. This machine, by the way, I think had 40 columns and originally like 8 rows of text or something. I mean, it was kind of like a Commodore 64 in terms of its display. Very, very primitive stuff. And it's a funny story about this. The display memory used this acoustic delay line technology that there was like a little transducer and some medium that it would send standing waves of vibrations through as memory to figure out what to display on the screen, so that if you like stamped up and down next to it, you would modify what was on, create like little noise on the display. I don't think that was very popular. But anyway, the operational analytical divide is emerging here. People are casting about with database ideas. To what these days, when we say database, maybe you are a Mongo person and you think of a document database. That's like a first-class option now. But by default, we think relational tables, SQL. Even if you are a Mongo person, you go in the documentation for the, how do I query this thing? And it says, well, this is like in SQL, where you say select where, So, that's just how we think about data. Well, that wasn't a thing until this guy named Ted Codd in 1970 published a paper called A Relational Model of Data for Large Shared Data Banks. It's a very old-timey way of putting it. I think we should start saying data bank. Just try that in a meeting. Just instead of saying database, say data bank. Do not explain yourself. Just keep saying data bank and refuse to answer questions about it. Just try it. See how that goes. Maybe we could bring that back. But until now, the business databases that various companies, not just IBM, were developing were either hierarchical, so like a file system where you've got folders and things in it and properties, and it's this nested, or like Zookeeper, I guess, would be a hierarchical database that is a little bit more contemporary, or what they called network, or a graph database. So no, Neo4j was not the world's first graph database. Graph databases predate me. And so this guy Codd comes along and says, no, how about we do tables and we have these relationships and this algebra where we can do various things with these tables. And people were like, cool story, bro, and largely ignored him for most of the 1970s. People are trucking along with their hierarchical and network databases. And life goes on. Somewhat smaller, cheaper mainframes that we call mini computers enter the chat in the 1970s. This, well, on a personal note, is the first machine, I guess I've done the Computer History Museum demo on the IBM 1401, but like I'm not old enough to have used a 1401 in real life. In high school, I modified some Fortran code on a VAX 11780, so that's like as close as I've come. It's pretty, so I'm basically an expert. But yeah, these were easier to power. You could like plug them into normal power in many cases, and cheaper, but still architecturally like mainframes. It was this one big thing. Here's the storage. Here's the I/O devices. Here's the software. Here's literal terminals. And by the 70s or 80s, you might have had some cool color terminals and things like that you could do. Again, I saw some of those in the mid to late 80s as a teenager. But architecturally, it's not different. They were billed as a separate thing, but it's still basically the world of the mainframe. This slide is red for reasons. And in 1979, Oracle is founded, and they have a product called the Oracle Database, which is based on the just 9-year-old relational model that Edgar Codd published in 1970. So this is essentially the first commercial relational database. Took 9 years for that to be a thing. And it's not like the battle was over. Okay, there were still lots of crazy different database types. Databases were not relational by default in the 1980s, but a lot is happening here. And, all right, I've got a little note. Nobody said client server in 1981. August 12th of 1981, I had just turned 9. I was getting ready to go back to school. I was going to be 4th grade, and that was pretty cool. And I had no idea that there was this company called IBM that released a thing called the PC, but they did. Now, Apple had been making personal computers for a few years. There were lots of them available if you kind of knew the right magazines to go get at the grocery store. There were cool ads for these things, and they were, a commonplace thing among maybe slightly nerdy kids like me. But IBM made this sort of boring business version of that. And you've got, for the first time, all the compute, all the storage, an interesting display, I/O, all of it is cheap enough to put in one box, put it on a desktop, plug it into the wall, and you don't have to be the president of the world to be worthy of a computer. Maybe you have to be somebody a little bit important, but frankly not all that important. Okay? You can be a very forgettable middle manager somewhere who no one will remember after you die and your kids die, and you're cool enough to have a computer. So that is an interesting development. Now, increasingly, through the 1980s, knowledge workers on their desktop get PCs, PC compatibles, all this software, all this stuff starts to happen. 1982, WordPerfect 2.2 is released for the PC. So WordPerfect itself, if you... Can I have hands for the first time? Who has used WordPerfect? Let's do that first. That's good. I appreciate that. And hands down, is there anybody who hadn't heard of WordPerfect before this slide? I would love to see hands. Love it? Okay. Thank you. Yes, I see you. Excellent. Well, tell you what, this was really cool software in the 80s. I didn't become aware of WordPerfect until a few years later, version 5.1, and that was just the apotheosis of text-based word processing software. I can't even tell you. It was so good. It was so powerful. But now, here's this thing. I don't have a typewriter. I don't have a professional typist that types things. I can do that on my PC as just regular old, sort of not very important office worker. IBM releases a relational database in 1983. That's not going to be running on PCs just yet, but just kind of, again, going in time order here, the relational model is certainly picking up steam, and more software is being developed for PCs. Lotus 1-2-3 wasn't the first spreadsheet. The first spreadsheet, the idea of the spreadsheet, was created. It was a program called VisiCalc, made in 1979 for Apple computers. That was revolutionary. Lotus 1-2-3 and WordPerfect together kind of became the killer apps for PCs in the 80s. And something big is happening here. PCs are being connected to each other. So there are various expensive, mostly IBM-y ways of networking PCs. 1983, we get this standard called Ethernet, which is this cheaper, easier way to connect computers, because with those files you're creating, the spreadsheets, the WordPerfect documents and all, how are you going to exchange those, right? Well, we need to connect these computers over a network. This is a very different paradigm. So it's nobody is calling it by its name client server yet. That's not really a term that shows up in the press. But there are now these little networked computers, not the one giant computer that is sort of maintained by a priesthood that you're not allowed to touch, that they'll give you a terminal and they'll let you log in and run your batch if you ask nicely. But now there's a computer on your desk, data that you control, and data that you can exchange with other machines. That is a huge paradigm shift. And it's the first time, 30 years of mainframes, and now there's a new idea. And people begin to recognize how important that new idea is. Like I said, the relational model was by no means standard here. There was DBase 3 was an incredibly popular database management program throughout the 1980s, not relational, big, strange, weird thing. Since we're talking about the timeline, 1985, I enter the chat. I know it's a lot to deal with there, but 1985, pictured with a non-PC compatible Victor 9000, either writing GW Basic or 8086 assembly language. I don't remember exactly what I was doing in this picture. It was a while ago. But I was there, and yes, I dressed like that all the time. Now, by the end of the decade, by 1990, people have described this new emerging paradigm. It's already happening, but these things happen, and you don't always know what's happening when it's happening. And people are starting to say, wait a second, this is huge. Because now we don't just have massive computer over there, we've got all these little clients running interesting software where the data is being stored on a server on the LAN. And that's all inside the office, okay, or maybe some offices are connected if you're big and fancy, but it's just there's a computer over there with the data in it. And that client at first is some DOS-based text thing, because that's the best we can do. And then, we start to make nice Windows programs with Visual Basic and everything. And that database, rather than being like at the beginning, you had to be a government, an airline, a bank, a utility. You had to be important. Now, you could be, that database could be ruled over by some little minor departmental executive, some director level person who's got his own budget for applications. There's smaller budgets, but there's more data and there's more databases. And so now rather than one computer and one place where all this stuff lives, there's all this data all over the place. And again, when these revolutions happen and you're there and you're just trying to learn the next tool and you're like, DBase, what the crap is that? Okay, I used to write COBOL. I guess I have to learn DBase now and Nova and NetWare and PCs and you're just lost in the details trying to do your job. You don't see the paradigm shift happening, but there's a paradigm shift happening. I mark the beginning of the client-server era in 1981 with the introduction of the PC. Even though networked PCs were kind of a little rough then, it's 30 years from the first commercial mainframe to the first PC in the client-server era. And this was a huge and disruptive thing. Completely different way of designing applications, of connecting computers, of storing data. What now if you want to look at the whole state of the business? Well, the data is scattered everywhere. It's in 100 little databases that are running under somebody's desk on a little departmental database server. That's just a slightly larger PC. Well, these changes have their impact. Unknown to pretty much anyone, we have the first HTTP server running in 1990. We have the HTTP spec published in 1991. It is a beautiful piece of technical prose, beautiful because it is short. That'll be back in a minute. And the modern concept of the data warehouse by 1992, Bill Inman publishes Building the Data Warehouse. That operational analytical divide that I talked about that wasn't a thing at the beginning of computing, it is a massive thing and a massive problem now. And so the idea of going to all of the operational databases, which are scattered and everywhere, and extracting that data, pre-processing it, transforming it, putting it in this other specialized database where we can do our analytics, since Adolf Quetelet gave us the idea of analytics now almost 200 years ago by this point, that becomes an actual discipline, and that operational analytical divide becomes an unbridgeable chasm. Because of this thing, with all of these databases everywhere, the data warehouse says we'll take all those things and put them into one place through this ETL process. And that becomes completely entrenched, and kind of still is. I think that might be, at this point, increasingly a historical artifact, but we often still think this way. I mean, Snowflake exists, and that's a data warehouse. All right, moving forward. 1993, NCSA Mosaic is created. Just a year later, that same guy says, no, I don't want to work on that one. I'm going to make another one called Netscape Navigator. Mark Andreessen starts Netscape, and Netscape Navigator 1.0 is released, and the era of the web has begun. Now, this would seem like another huge paradigm shift, and in lots of ways it is, but less than you think. At least less than you think right away. We'll get there. 1995, the Swedes give us MySQL. So by this point, the relational model is pretty much entrenched. 1990, people are still talking about object databases and some kind of strange things. But by this point, it's kind of done. Oracle's very standard. DB2, if you're an IBM shop. Postgres, Californians give us Postgres in 1995. And these are interesting as open source options, which is a highly controversial idea in 1995. No respectable company would do a thing like that. But they will eventually transform the way data infrastructure and infrastructure components in general are adopted by technology companies. This is still the era where some salesperson can play golf and drink martinis with your CIO, and on Monday you can learn that there's a new database you have to use. That doesn't happen anymore, but that was still a thing back then. More kind of data warehousing stuff is really taking shape. Ralph Kimball publishes his view of data warehousing in 1996. The internet is, of course, a global phenomenon at this point. People are listening to screechy dial-up modems and buying dog food in ways they could never have imagined buying it, and the dot-com boom is in full swing. Google is formed in 1998 in a time when internet search really sucks. And the way people like us, and some of you were doing this at the time, the way people like us were building enterprise web applications. We're starting to pivot. That thing that you did with Visual Basic in 1993, well, it's time to update that, and now we have the web, so let's redo that as a web application. So I'm not talking about the way Yahoo or Google or eBay or Amazon at the time were building the web. They were doing very custom things. Ordinary enterprise software developers building web applications. The Enterprise Java Bean spec is published in 1999. And that gave us what we called the 3-tier architecture. You had the presentation tier, which was a bunch of really sucky HTML in very primitive browsers. And if there was any JavaScript, it was a little toy you used to make something glow when you mouse over it. Okay, you didn't have React then. It was awful. And then you had the business tier, which is where all your Java beans or your servlets or whatever ran, and that's where your business logic was. And then your data tier was just the database. Okay, good old database. Now, if you will, they are the same picture. This is not materially different than client server. And there's a good reason for that, because the folks who were building this web in the late 90s, some of them were the wild-eyed maniacs who were preaching the gospel of client server and how it was going to liberate humanity from oppression and feed the hungry in 1988, 1990. It wasn't that much time after client server had taken over, so we're just taking our tools and building this new thing with those same tools. So the web happens. The web transforms our lives in so many ways, doesn't really transform common application architectures, doesn't transform anybody's data architecture. The data warehouse that you had before you did your enterprise web, you got the same stinking data warehouse now, and it's fine. It is kind of undisturbed, and so there isn't really a reason to do that. So dot-com bubble bursts. March 10, 2000 is the peak, local peak of the NASDAQ. That's kind of marked as the popping of the dot-com bubble. And it's a dark few years, but things happen. 2003, Google publishes a paper on a thing they call the Google file system. Okay, that is going to have effects. Just note it. We're going to come back to it in a minute. In 2005, a guy named Peter Rogers, there's all this talk about web services and SOAP and WSDL, and these things are all happening. So we want these kind of chunks of software that we can synchronously call with a HTTP request and send them some XML, and we'll get some XML back. We want our functionality to be composed of these services. Amazon is doing this at scale. And he says, we could make them really small. You could have call them micro web services. And he used that phrase in 2005. Setting the stage. Again, this happens. Nobody really cares. Web services are being used, also highly criticized, not globally successful. But that Google file system thing that happened 3 years earlier, well, now in 2006, Hadoop is created. This is the first sign that that data warehouse paradigm that we had been very comfortable with a few years before wasn't cutting it. But this was only happening at giant companies like, well, Yahoo is the company that made the investment in that, because they actually had a need for, they had that much data and had need for tools like that. But most of us didn't. Most of us were still fine with the databases we had. And that starts to break. And nobody knew, just like when the PC came out, nobody knew, oh, hey, it's client server just happened. It wasn't obvious at all. Well, smartphones, 2007, you have the iPhone, not the first smartphone, but the beginning of real serious smartphone penetration, kicks off a period say a period of aggressive change for the next few years. Now, increasingly, we've got smartphones in our pocket. We're starting to have more of our commercial and social lives mediated through internet-connected devices. Before this, to use the internet, remember, you had to go to a computer and quote-unquote get online. That phrase now sounds like Living La Vida Loca playing on the radio. Great song, okay, but puts you in a certain historical frame of mind that's not now. All right, you don't get online, you're just connected because you have a phone in your pocket. So now with smartphones and all of this data being created, we see the NoSQL revolution in 2010. MongoDB is formed, that's in 2009. They actually had pivoted to be a database company in 2009. A couple of Hadoop companies form. Cassandra is open sourced, actually 2008, but kind of centered around 2010, there's this flowering of databases, all oriented around this idea of data that is huge. So data is now huge. The internet isn't new in 2010. It took the internet plus mobile devices to begin to suggest to us that that previous architecture, client server plus the data warehouse, that maybe those weren't going to work. And you can't tell when the era begins that the era is beginning. So I'm going to mark, because I like that this is 30 years after, remember I said 1951, mainframe era, 1981, client server era. Nobody called it that, but this is my presentation. I get to set the eras. That's 30 years. Another 30 years to 2011, the open sourcing of Apache Kafka, and that's the era of events. Nobody knew. Nobody knew at the time exactly what was happening. But also that year, 2011, somebody first known use of the term in print, microservices. The year after, over in, well, relatively nearby Krakow, James Lewis, a guy from, I think, ThoughtWorks at the time, gave a presentation on something he called microservices. Now, those were not old SOAP web services, but smaller. This was really a different application architecture, a way of saying, hey, instead of this thing that was now bad, this thing we call a monolith, you want to make it sound like Darth Vader or something, let's take that monolith and break it up into a bunch of programs and have them talk to each other. That is a different way of saying the client-server paradigm can no longer help us. And we need to break that into smaller pieces and that big application into pieces that communicate. This mostly sucked for, I'd say, 5 years. Okay, a lot of early microservices implementations were failures. It was difficult to work with. There were a lot of bad ideas. We didn't quite understand how to do it. Company I happened to work for was founded in 2014, based on Kafka, and a lot of the thinking in the Kafka space helped drive the thinking around microservices. It was clearly this very compelling idea that had a lot of steam behind it and a lot of energy behind it that wasn't working very well at first, because there were some failed ways. You know, you take a perfectly sensible program and break it into pieces, and how do you get those pieces talking again? Well, there were a lot of bad ways of doing that, and eventually people seemed to stabilize by later in the decade on the idea that maybe durable event logs were a good way to get these pieces talking. So you've got a new application architecture that's very different than the way before. Just like in 1985, if you were an experienced COBOL programmer being told you're going to write DBase on a PC talking to a bigger PC with NetWare, now you're like, I know how to do Spring MVC and crappy HTML on the front end with maybe slightly less crappy JavaScript by 2015. Much less crappy JavaScript by 2015. Let's be fair, it was fine. There's still no React, but it wasn't 1998 anymore. But, I knew how to do my Spring MVC apps with my database that I owned. That was a great life. Now it's different. It's the same kind of paradigm shift. So I'll put that differently. The kind of paradigm shift that we're living through right now in the unfolding of what I'm calling the era of events has only happened twice in the history of digital computing. One when mainframes gave way to client-server, and now when that client-server paradigm is giving way to this broad space of data streaming and event-driven architecture. You get things like Apache Pinot, which is a real-time analytics database. Well, why mention this? I spent a lot of time working with Pinot, but also just like when you had mainframes give way to client-server, you get this new application architecture. Now with this new application architecture, back then, you had data warehousing emerge. We have to handle analytics differently. Well, now we've got, rather than data necessarily being in 1,000 databases, which it kind of still is, increasingly it's in 1,000 Kafka topics, and we're starting to see different databases that are more shaped like that world of data streaming. So we're seeing the same disruption in analytics in this paradigm shift that we saw in the last paradigm shift. So let's sum up, because it's almost time. 1951 to 1981, we have the mainframe era. 81 to 2011, we have the client-server era. Look at that symmetry, 30, 30. It's so pretty. And from 2011 on, we have what I'm calling the era of events. And we've had some other kind of things that we layered on top of that. The web from maybe 1991 could be its earliest possible beginnings. And these disruptions that happened, right? Like, that was a little unpleasant in there. It was the 80s. Everybody's having a good time. It's kind of fun. Good, fun music, bright colors. Everything was great. Kids were afraid of nuclear war, but it was a nice time in retrospect. As in the software community, if you were making that transition to client-server, it was a mess. All these different frameworks, products, approaches, incompatible types of computers. It was a little bit weird, all right? And there, when we're first getting started with microservices, it was a good way to die. I mean, it's not anymore. We kind of know how to do it, but it wasn't at first. So when we see these transitions, it's a little unpleasant for a little while. And I was talking about trying to collect threads. We had this long period of mechanical computation, then digital computation, and then with data storage on top of that, we had databases emerging. Then on top of that, again, mainframes, client-server, events. This basic kind of look at these, I'm asking you to look at these things that are happening over time that all come together to where we are now. Which is what? Where does that bring us? If we collect these threads together and try and weave them into something that makes sense, where we are right now is in a place where data streaming has become the new default. There's a new universal data substrate. It used to be whatever database you happened to be using. It was Postgres, it was MySQL, maybe some life choices had happened and it was Oracle. I don't know. But it was some database back 10, 15 years ago. Now, that universal data substrate is increasingly just Kafka. On top of that, somewhere, you've got the code you actually write that does something useful for the people who use the code. Is it an internal tool? Is it something customer-facing? Code that actually does something to serve your customer is kind of what you should be doing. But in these times of transition where things are confusing, there's a lot of stuff in the middle, right? And it's not always clear. Between Kafka and me, I've got lots of choices of different pieces of infrastructure that I can use to solve different problems. And we don't even necessarily know what all those infrastructure components are, because it can take more than a decade for that kind of situation to stabilize. And it's never absolutely stable, but even so, we don't always know what those things are. And it can be difficult when you're trying to focus on, I'm trying to write this code to serve a customer and do a thing that's actually different than what a competitor does. there could be temptation to kind of dive down into that unknown space between Kafka and you and invent layers of infrastructure. Maybe you'll make a bad call on a choice of infrastructure because it's not clear what a winner is going to be. It's very confusing in there. It's also kind of cool to be living through this period in history. And I think I'm very sure this is an era of a new paradigm. We're in the era of events. And just like that, we've come up with terms like data scientist and data engineer and things like that. I think increasingly those of us who are building systems, event-driven systems on top of Kafka, increasingly, we are being unified as people who work in the streaming world. And I think I've been using this. At Confluent, we've been using this title, data streaming engineer. This is kind of the new software developer, and frankly, software developer is just a fine term that I think we can all continue to use. But in a real sense, in this era that we're all in now, this massive paradigm shift, biggest one in a generation, it's going to last for at least a generation. In a real sense, we're all data streaming engineers now. So with that, thank you for being here. Have a great rest of your morning.
All systems are nominal. Initialize Genesis sequence.